Good morning, students. Can you hear me? Is it coming in soon?
Continue.
Good morning, students. In today's class, we will be studying about the practical. Especially, we are going to study about the theory portions of the practicals. I will be following in this book called as BSc Practical Physics book by C.L. Arora. Okay, if you are interested to take major in your physics in the 5th and 6th semester in the final year, then you can buy this book. Okay, otherwise, no need. Okay, this copies are available in the library, and we will also be giving you the notes and the PDF from this books. Okay, for time being, we will do that because of the online classes. Okay, so if you're sure that you are planning to take the higher studies in physics and you will take the majors in physics, then you can go ahead buying this because this may be useful for you even in your MSc. Okay, BSc Practical Physics from C.L. Arora. Okay, so the experiment here is in page number 58. Okay, in this book. Okay, this is about the determination of the modulus of rigidity of a given wire using Maxwell's experiment. Okay, this will be your experiment number 3. Okay, since you are studying about the elasticity in the syllabus, theory syllabus, and this is a practical related to that. Okay, so experiment 3 will be determination of modulus of rigidity by a method called as Maxwell's vibrating needle. Okay, I will draw this diagram and I will send a suitable video about this experiment in the group. Okay, now here you have a rigid support. Okay, a stand will be there. Okay, and this is called as a torsion head. Okay, this is a fixed head. We call it as a torsion head. This is called as the torsion or a fixed head. And from here you will fix a wire, okay, a thin wire whose modulus of rigidity has to be found out. Okay, so that wire will be fixed over here. Okay, and it will be hanged to, it will be fixed to the other end, is fixed to the Maxwell's needle. Okay, Maxwell's needle is like a type of a cylindrical it is a hollow cylinder. Okay, it will be a hollow empty cylinder, like a cylindrical tube. Okay, in which this is called as the Maxwell's needle. Okay. Inside this needle, you can put two cylinders. Okay. One cylinder will be a solid cylinder. Okay. This is a solid cylinder. And another will be two solid cylinders. Okay. You can take it and put it. And one will be a hollow cylinder. Means it will be an empty cylinder. It is a very lightweight one. There will not be anything in it. But this is a solid. Inside also it's a fully a metallic piece. Okay. So in this experiment, what you will do is you will put the solid cylinders. Okay. First, the position of the solid cylinders. Okay. Keep the solid cylinders outside. The first part of the experiment. Okay. You will keep the solid cylinders outside. Okay. And before putting that, you will put the hollow cylinders. Okay. These two will be your hollow cylinders. Here I have to put it. This will be the hollow cylinders. Okay. Okay. What you do is you can, it's because a hollow one. Okay. This is like a cylinder here. Okay. I can imagine that I can put this one inside it. Okay. So hollow cylinder will come inside here to see, this is a hollow one, right? There is nothing in this. I can put my finger here, hollow. Like this, there will be hollow tubes that I can put it inside. Okay. And a solid one will be like this. No? It's very solid. I cannot put it. The whole thing will be solid. Like that, there are two solid cylinders that you will keep it outside here. Okay. So I'll repeat, the hollow cylinders will be inside. That will be the first part of the experiment. The solid cylinders will be outside. Okay. Concentrate on one. Concentrate on the solid cylinders. Okay. In the first part of the experiment, you will keep the position of the solid cylinders will be outside. Okay. And the solid hollow will be inside. Okay. With that position, what you will do, you will twist this slightly. Okay. It will be hanging like this. There is a wire here fixed over here. And this is a vibrating needle, hollow needle. And you can insert it. Insert the hollow cylinder first. Okay. Imagine that suppose I have like this, right? If you open this and you can put the refill link, isn't it? You're putting that inside, right? Like that, you will put the hollow cylinder inside and then the solid cylinder will stay outside. So it will become a heavy mass now. And you will twist this. You will vibrate it a little bit like this and then leave it. So what will happen? This will start vibrating like this. Okay. And you have to count the number of oscillations. Okay. Allow it to go from here to here and then come back. Okay. You will be given a stopwatch, okay, a watch to measure the time. And once it starts from one position to the other position and come back to the original position, you will count the oscillation as 1. Like that, you will count 10 oscillations. So what you are trying to do is, using this weight, okay, you are trying to give a twisting couple to this cylinder, to this needle. Maxwell's, this needle is called as a Maxwell's vibrating needle. And this wire is being twisted, okay? And you are giving a twisting couple to this one, okay? So ultimately, you are trying to find the modulus of rigidity because this is related to the twisting and there is a shear, that is shear stress is given, and you will calculate the modulus of rigidity of the wire by taking the length of the wire as small n, okay? This is the entire, it may be 30 centimeter, you can fix it, or 45 centimeter according to your wish. You can take the length, but the length has to be measured using the meter scale. And then before starting the experiment, you will keep the wire, okay? And then take the radius of the wire at 2-3 points, okay? Using screw gauge experiment, okay? So here you will apply the screw gauge. Okay, so you have to draw the screw gauge tabular column also for this experiment to find the radius of the wire. So one tabular column is to find the radius of the wire. Okay, so the radius of the wire is given by R. You will find the radius of the wire R. Okay, and then you will take the hollow cylinder. There are two hollow cylinders. You can take one hollow cylinder and measure it. Both will be having the same weight. Okay. So that will be your M1, okay? And this solid cylinder mass, you will measure it. That will be your M, I think this is M2. This will be your M, I think this is M1 and M2, okay? mass of this one is higher, M2 minus M1. Okay, hollow cylinder weight 1 and mass of the solid cylinder, you will take it separately using a spring balance, which is there in the lab. Okay, and then this length you will measure. Okay, this length, the total length using the scale, if you measure it, it will be called as the half length. Okay, this length may be 40 centimeter. Okay, and you will take it as half length. Okay, divided by 2, you will get the half length. Okay, so this you will divide it by 2 and you will get approximately 20 point something. That will be called as the half length of the Maxwell's needle. So capital L is called as the half length. Okay, half length of the Maxwell's vibrating needle. Okay, it is called as the half length of the Maxwell's vibrating needle, capital L. Okay, you will take the full length of it. Okay, as capital, I mean, full length as 40 centimeter or something, 40.5 something, divided by 2, you will get the half length of the Maxwell's needle. That you will substitute as capital L. Okay, now we will go on to the formula. Okay, the modulus of the rigidity. There is a big theory that you don't have to write, just write the formula. Okay, the modulus of rigidity of the wire can be found out by eta is equal to, there is a formula for it. Okay, there is a big theory that is there. Please go through it and study. Because of the this one online classes, we are not going to detail of the theory. Okay, you will write this formula correctly. Okay, eta is equal to 8 pi into I into L. 8 pi L. Okay, M2 minus M1. Okay, into L square. Okay, divided by T2 square minus T1 square. Okay, into R to the power of 4. Unit of this is Newton per meter square. Okay, it is actually what shearing stress by shearing strain, isn't it? And this doesn't have unit. This one will be force per unit area. So it is Newton per meter square. Okay. Now, what is this length? As I explained, L is the length of the wire. Okay, it can be according to your choice. It can be 28.5, 23, whatever it is. After you fix it, you will measure it from the top edge to the edge where you fixed it to the Maxwell's vibrating needle. Okay. Now this is M2 mass of the solid cylinder. Okay, M2 mass of the solid cylinder. M1 mass of the hollow cylinder. Okay, T2. Okay, is a time period. Is a time period of oscillation. Okay, and write it here. T2. Time period of oscillation. Okay, when the solid cylinder is outside. Concentrate on one thing. Okay, concentrate on the solid cylinder position, and when it is outside, you will put it into that position, try to oscillate and take the time taken for 10 oscillation. Okay, that will be your experiment. It will be in one tabular column and you will get the result from one tabular column. Okay, so you will draw this, and the next one is T1. Okay, the same thing, time period of oscillation when the solid cylinder is inside. Okay, rearrange the position and place the solid cylinder inside and repeat the experiment. Try to twist it and then try to oscillate it and try to take the oscillation for 10 oscillation. Usually we give 2 times the trial. Let's see, because of the time we may restrict it to 1 or 2 oscillations trial only. Okay. Now after doing this, and this will be the radius of the wire. Okay, this has another tabular column, and you will try to find the radius of the wire. Okay, and then you will substitute the value in the formula, and you will try to get the modulus of rigidity. Okay, don't worry, it will look little confusing for you at this time. The suitable video, I have seen 4 or 5 videos, and I have selected the right video, and I will post it after this class. Go through this one. Okay, you will be able to understand, but they are using a telescope arrangement which we may not use it in lab, okay, due to some reasons. Okay, but the same experiment will be done. You will note down the time and take it, only except the telescope that we may not use, but all other things will be the same. Okay, so this is a theory portion. Okay, write the aim apparatus and this formula rightly and the related things rightly, and then you will draw the tabular column. Okay, position of the solid cylinder. I will give you the this one. Okay, I will send the picture of it. Okay, position of the solid cylinder when it is outside, and position of the solid cylinder when it is inside. Okay, the tabular column will go like this. The first one will be the position of the solid cylinder. You cannot concentrate on both the cylinders, so concentrate on one position of the solid cylinder only. Okay, when the solid cylinder is outside, okay, that means in the tube. Okay, the solid cylinders, the shaded ones are solid cylinders. Okay, so when the solid cylinders are outside, automatically you will know that the hollow is inside. Okay, so this will be the first part, and you will note down the time period as T1. Okay, so here the time period will be T1 and T2. Okay, you will find out what is T1 here. Okay, so outside and then inside. You will take the time taken. An oscillation is enough. You will do trial 1 and trial 2. So draw this tabular column in your notebook. Different people has their own way of tabular column, but we follow this one. So this you can draw it. Okay, watch the video for the experiment, but draw this tabular column which we follow it. Okay, trial 1 and trial 2, and then the mean. Yes, of course there is a mean here. Mean value you will take it. Okay, the mean of these two, and then time period is what? How many oscillations? Suppose you are getting 256 seconds. Okay, suppose you get 2 minutes and 33 seconds. So 2 minutes will be, this is in minutes, no? 2 minutes you will convert it. 2 into 160 you will convert. Okay, so this will become 2 into 60 will be 120 plus 33. Okay, so this will become 153. Okay, suppose it is 153 seconds. Okay, convert everything, the minutes into seconds, and then this will be 153 seconds for 10 oscillation. So time taken for 1 oscillation means what will you do? You will divide it by 10 and you will put it as 1.53 seconds. Okay, that will be your time period value. Okay, so you will write it as 1.53 seconds here. That is as T1. And T2 will be another value. Like this you will get it. 2 times you will do this experiment. Here you will do 2 trial, here you will do 2 trial and take the mean. Note down the time period as T1 and T2. All other values you will get it. And you will draw one tabular column for the radius of the wire. Okay. You will, on the top you will put it as to find the radius of the wire, of the given wire using screw gauge. Every tabular column should have a heading. Okay, screw gauge, and then you will draw the this one, right? Main scale reading, circular scale reading into least count. Okay, and then total reading will be your main scale reading plus CSR into least count. Okay, you will take 1, 2, 3 in the different part of the wire. Maybe on the top portion you will put the screw gauge and take one reading, middle में एक बार करेंगे, then third one at the last, 2-3 places you will take. So 1 or 2-3 readings you will take. Find the mean radius. Okay. And then you will substitute in your formula and ultimately you will get the modulus of rigidity of the wire. Okay. So this will be the third experiment. Actually speaking, we will not give you the screw gauge and the vernier experiment as a separate experiment for examination. Mainly these 3 experiments, G by power pendulum as a first experiment. This will be your second experiment. The third will be your another experiment which I am going to explain. This will come, but these 2 experiments involves the usage of screw gauge and vernier. So for that, we will teach you the screw gauge and vernier in the beginning. Okay, so that experiment alone will not come for examination, but either one of these 3 experiments will come for your examination. You have to perform one experiment and get the value correctly. Individually, you have to do one experiment. We will write the experiment in a sheet and you will not know it, and we will keep it. You will have to take it in a lucky draw. One, you have to take it. We may keep 10 experiments in this written one. You will draw one and you will read your concerned experiment in the examination and you will perform that particular exam in the examination. Perform that experiment in the examination. Okay. So that I will explain it when you are coming for the practicals. Okay. Now, hope this is clear to you and I will send the video, watch it, but draw this tabular column that will be useful for you. Okay. Now we will move on to the next experiment. Due to this limited time, we will only concentrate on this 4-5 experiments only. Okay. Later on, let's see how we can do it. Now, the last experiment here is to find the modular, to find the elastic constants. Okay. So the 5th experiment, that is experiment number 4. Now this is experiment number 5. The last experiment is to find the elastic constants. So what are the elastic constants you have studied? You have studied about the Young's modulus, modulus of rigidity, right? And then bulk modulus and the Poisson's ratio, right? So in this experiment, particular experiment called as finding the elastic constant using Searle's experiment. There are 2 things, okay? One is Searle's experiment and another one is called a Searle's method. Don't go into that method, okay? That's another type of experiment. This is a Searle's experiment, okay? 1 minute, let me search where it is. It is there in section 5.6 in this book in page number 64, okay, in C.L. Arora, okay. Practical Physics by, the book name is Practical Physics by C.L. Arora. Okay, if you are interested, you can buy this book. It is called as BSc Practical Physics by C.L. Arora. It's there in page number 66. And the cost of this book is $4.95. Okay. For time being, you don't have to buy. Okay. Just follow it up and send you the PDF of this particular experiments that's given here. Okay. So page number 64, it is there. And the theory portion is also there in your book. The prescribed book also has a theory portion. From there also, I will tell you the page number. You can go through it, the theory portions. Okay. And go through the oral questions, like small Viva questions that can be asked in this. Okay. 64. This theory portions, I will send it to you by tomorrow. Okay, one by one, I will send it to you. Okay. Now, this experimental setup, I will explain you. Okay, by the Searle's experiment. Keep this in mind. Shall I rub this? Now, the Searle's apparatus will be like this. Okay. Here you have a stand like this. Okay, and okay, let me explain first. There are 2 bars. Okay, there will be 2 bars like this. This bar can be a cylindrical bar or it can be a rectangular bar. Okay, both are there in the lab. Okay. You need to find the moment of inertia of these two bars. Moment of inertia. Okay. So for the moment of inertia, you have a formula for it. Okay, that you have to use it to find the moment of inertia I. Okay. I is equal to m into L square plus B square by 12 is it. Okay, this is for a rectangular bar. Okay, so you will find the moment of inertia of the bar by taking the length and the breadth. Okay, length you can use the scale and measure it. For the breadth, what will you do? You will use the screw gauge here. Okay, so you will draw a tabular column for finding the width or the breadth of this bar first. Okay, and you will substitute here length and the breadth and the mass. One bar you will take it, measure the mass. We have a spring balance. We'll measure, find the moment of inertia first. Okay, the next part of the experiment is these both are two identical equally length bar. Okay, a rectangular bar. Sometimes we may in the exam we may give a circular bar. In that case, this instead of the breadth, you will there is a formula. The formula will change. It will be with respect to radius. Okay, and that radius formula you'll have to put it. I'll let you know, and then that you will substitute. Okay, for time being, let's concentrate on a rectangular bar. Okay, and in between this bar, okay, your experimental rod. Okay, this will be your experimental rod. For this rod, we will ask you to find the Young's modulus and the modulus of rigidity. Okay, this is your experimental wire I can call, or a rod, because it's not a very thin wire, it's a little thick wire. Okay, like this type of this one is there, isn't it? Nail is there, isn't it? This much thickness it will be there. So I cannot call it as a wire, I have to call it as a rod. It is a little thicker one. Okay, like this, but it's a little long length, 30 centimeters like that, it will be there. Okay, and then that will be fixed inside this. Okay, in between. Okay, imagine that I'm fixing this, and for this wire rod, I'm asking you to find the modulus of rigidity and the Young's modulus. Okay, so but it is flexible. Okay, it is like not a very hard one. It can twist, it can also be bent. Okay, so that wire you will fix it. Okay, and that length also you will take it as L. Okay, and this length will be capital L. Okay, this is capital L. Breadth you will find it using vernier. Okay, vernier caliper. Okay, this length of the rod you will find it as small l. Okay, can be 29 centimeter or 30 approximately. It will be 30. Okay, now after fixing this, there will be a hook over here, and you will fix it to a top one. Okay, to a stand. Okay, these two bars. Okay, are suspended by an equal length onto a stand. Okay, there will be a hook over here. Okay, you will take some approximately 40 centimeter in a thin wire, no? Thread. Actually, we will give you thread, so you will fix these two. Okay, onto this one, and this will be a fixed stand. Okay, this will be a fixed stand like this. Okay, initially what you will do, you will bring it close to each other and make an arc shape. Okay, make it into an arc shape. Okay, try to bend it. Okay, so you will put it in this way. Okay, and try to bring it closer. Why you are trying to do? You are trying to give a bending couple to it. Okay, you are trying to find the first part of the experiment is to find the Young's modulus. Okay, to do that experiment, this wire, this is the experimental wire. This is an experimental wire that will be bent by making an arc to the both the rods. Okay, and then you will use a small thin wire, thread. Okay, the stitching thread. Okay, the threads which are used for stitching purpose. In using that, you will just make a wind up like this. Try to tie it up both together. Okay, and then use a matchstick or a candle, light and allow it to burn it. Once it starts burning, this will start, both will start twisting like this. Okay, this will start twisting like this, right? Once this wire is torn, okay, immediately what will happen? It will get released and this will start twisting like this. Okay, and this also will start twisting. But concentrate on one. Any one you can concentrate, and this will make an oscillation like this quickly. So start your stopwatch from here and take the note down the time taken for one oscillation. So once it goes from the, once you allow it to come here and start. Once it goes and come here, it will be 1. Again, when it goes and come here, it will be 2. Again, it goes, comes here, it will be 3. Like that, you will take the count the 10 oscillation, and at the same time, you will be given a stopwatch. You will start the stopwatch. Okay, note down the time taken for 10 oscillation. You cannot concentrate on both, but one you will concentrate. So what you are trying to do is you are trying to ultimately see how much this can undergo a bending, like it can oscillate. Okay, so ultimately this sample Young's modulus is measured in terms of the vibration of this particular rectangular bar. Okay, this is called as bar. This is called as a rod or a wire. The experimental rod or wire. Okay, so ultimately Young's modulus can be measured in terms of the vibration of this particular bar. Okay, so you will note down the time period as T1. Okay, and then this is the first part of the experiment. So I will now I will write down the formula for this. Okay, the Young's modulus can be found out using the formula as is given by okay, this will be the time period that you will note it down. Okay, how will you note down the time period? Let me draw the tabular column. Okay, it's a simple one. Okay, time taken for 10 oscillations. 1, 2, 3, 4, 5. You will do it. Okay, note down the time in 2, 3, 4 experiments. Okay, and then take down the time period. Time period means suppose you have 12 seconds, it's coming. Okay, you're oscillating for 10. Time period means you will put the 12 divided by 10, which is 1.2 seconds. That means time taken for one oscillation. Okay, this will be your T1. Okay, draw it. Similar tabular column, you will draw it for T2 also for the next part of the experiment. Okay, T1 and T2. So two tabular column like this, and then a vernier caliper tabular column for finding the this one you will have to find the radius of the wire also. Radius of the wire. See, this is an experimental wire, na? So in this wire, again 2, 3 places you will take the radius. So you will have 4 tabular column, one like this, another one for T2, and then radius of the wire. Okay, and then the breadth of the bar. Breadth of the bar using vernier caliper. So 4 tabular columns for this has to be drawn. One with screw gauge, one with vernier, and 2 for this is time period T1, and another same tabular column for time period T2 for the modulus of rigidity. Okay, so and moment of inertia, I said you will calculate it before. Length of the wire you will measure it. Radius of the wire you will measure it using screw gauge. Time period you will measure it from here and substitute here, and find the Young's modulus. This also will be in Newton per meter square. Okay. Now the second part of the experiment, draw the same tabular column and put it as T2. Okay, so you will write it here second time to find the Young's modulus of rigidity of the wire, the time period, to find the time period. Okay, T2 for finding the modulus of rigidity of the wire. Okay, same tabular column you will draw. Okay, the formula will also remain the same, except this will become T2 square. Okay, this will be eta. Same formula, time will be changed. T will be changed, but the experimental procedure, now I'll tell you how it will change, okay? In this part of the experiment, what will happen is, the experimental wire was like this, isn't it? In this experiment, you will fix, okay? You will fix the wire like this, okay? This will be your stand, okay? And in this, now the stand will be changed like this. Okay. You will fix a bar on the top. Okay, this will be this one, isn't it? This will be the stand. Okay. Now you will fix one bar like this. Okay, tie up this bar with this thread. You will tie it up. One bar itself will be fixed on the top, and the experimental wire will be kept here. This will be the experimental wire. Okay, and another bar will be kept over here. Okay, and you will fix with the hook and arrangement, you will fix it here. Okay, two bars, these are bars. Okay, these bars will be fixed in a horizontal position like this, and the wire is held in a vertical position. In the earlier case, in the previous case for the Y, what we did is we tried to put the wire like this. The wire was kept in a horizontal position. Okay, the wire was kept in a horizontal position between the two bars, isn't it? Between the two bars, the wire was kept in a horizontal position, okay, and allowed to bend. Now, in this case, the wire will be kept in a vertical position. Wire in vertical position, okay, between the bars. And now what will you do? You will twist this bar. Okay, this bar, one of the bar will be twisted like this. Okay, so this bar will go this way and this way, this way and this way and make an oscillation. So the twisting that you are giving through this bar and this wire, experimental wire, will also be twisted. You're ultimately giving a twisting coupled to this experimental wire through this bar, and you will calculate the modulus of rigidity of this wire, particular wire over here. Okay, so now you will allow it to twist and leave it. So once it goes here and then comes back, once this goes here and comes back, you will start the stopwatch and note it down as 1, and goes here and comes here 2, goes here and comes here 3. Like this, you will take down the time taken for 10 oscillation again. Okay, so in the tabular column, you will write it as the experimental wire is kept in vertical position. Vertical position for finding the modulus of rigidity. So second tabular column in time T2, you will repeat the same experiment for 2, 3, 4 times and note down the time taken and divide it by the number of oscillations, same way. This time it may be different. Okay, you may get 5 seconds, 4 seconds, it may not oscillate much. Okay, so the time taken will be different. So this will be 5 by 10, it will be 0.5 seconds, like that it will reduce. And note down the mean, okay, mean T2. Add up all these 4, 5 values and divide it by 4 values. Okay, if it is 4, you will divide it by 4 and take the mean T2. Okay, if you have performed it for 4 times, add up all the 4 divided by 4, you will get the mean T2 value. Substitute in this formula. All other things, factors will remain the same. For one time only, you will find the radius of the wire and the length of the wire. Okay, all other moment of inertia, you will know it from before. Only in this experiment, this T2 value will vary. Okay, when you substitute all the values, you will get the modulus of rigidity. Once you know the Young's modulus and the modulus of rigidity, you will use K. K is related with the formula, isn't it? See your book. K is equal to what? 1 by 3 into 1 minus 2 sigma. So you need to find the sigma value before that. Okay. So Poisson's ratio can be found out using this formula. Okay. The third part of the experiment. This is the fourth part of the experiment. The third part of the experiment is to find the sigma, Poisson's ratio. Okay. Once you note down the time period T1 and T2, okay, substitute it into the formula as sigma is equal to, use this formula, T2 square by T1 square minus 1. Okay, note down this. You will simply put down the T2 value, mean time period of oscillation for the calculation of the modulus of rigidity, na? T2, right? From this experiment, you will find T2, put it here. And the previous experiment, modulus of rigidity, when the wire is kept like this, na? When the wire is kept between these two, you will find the Young's modulus, isn't it? Time period T1, you will note it out. That you put it over here, okay? And then square, and then make a subtraction with 1. In this way, if you do it, you will calculate the Poisson's ratio. This value can vary from 0 to 0.5, right? So some value in between you will get it. That value you keep it, substitute over here, okay? And the Young's modulus you already know, you substitute. And if you put it in the formula, it's just a theoretical calculation, okay? You will substitute the Poisson's value that you get. Young's modulus already you would have got it, you put it, you will find out the bulk modulus value. So in this experiment, you are trying to find the Young's modulus value experimentally by finding the time period by keeping the position of the wire in the horizontal position first. And the bars here like this, okay? That time period will be noted, substituted in the formula, find the Young's modulus, okay? And next, the experimental wire is kept in a vertical position like this, okay, between the bars. And again, time period will be noted down and it will be substituted and found the modulus of rigidity, okay? And then knowing the two time periods, you will substitute in the Poisson's ratio formula and then you will get the Poisson's value. And then knowing the modulus of rigidity Y, knowing the modulus, Young's modulus Y, modulus of rigidity and the Poisson's ratio 3 values, you will substitute into the bulk modulus value, the formula, and you will get the bulk modulus. So in this experiment, all the 4 values can be found out for a particular material, okay? So since this is there in your theory portions, a suitable appropriate experiment is also given in your BSc syllabus to find the elastic constants of a material using a wire, okay? Hope this is clear and I will send the suitable video by tomorrow, okay? First, I will send the previous experiments one, Maxwell's one today. Tomorrow, I will send the cells experiment, okay? So finish off, write off all the theory and the experimental and the formula in your notebook clearly and keep it ready for 4th, okay? So hope this is clear to you and any doubts you can ask it in the, please ask it in your WhatsApp, okay? So actually the first experiment I will repeat will be the finding the radius of a wire, given wire using screw gauge. The second experiment will be again the radius of the wire, maybe a different wire, a different material using vernier. That will be your second experiment. The third experiment is to find the acceleration due to gravity using bar pendulum. The fourth experiment is to find the modulus of rigidity of the wire using the Maxwell's vibrating needle. The fifth experiment is this experiment to find the elastic constants using Searle's experiment. I will write it and put it in the group also, don't get confused. But in your examination, the third, fourth and fifth experiment only will come. We will not give you a simple wire and ask you to measure the screw gauge readings, okay? Since screw gauge and vernier are required for these 3 experiments, we are teaching you, that's all, okay? But it will not come in the examination, but one among these 3 experiments, you will have to perform in your examination, okay? And you, based on this theory, see again, you are seeing now what is Young's modulus, what is modulus of rigidity, what is the formula, what is Poisson's ratio, such viva questions, and what is G, what is acceleration due to gravity, what is its value, how does the G value vary in when you go higher, okay, in the, or when it is in the equator, or when it is in the middle of the earth, or when you go down the earth, okay, how the value of G varies. All such simple viva questions will be put up into a questionnaire form. We will ask you 10 questions, okay, on 29th, okay, on 29th is your exam. Please remember this, 29th of December, Okay, you will be given a small questionnaire for 10 minutes. The time may be 15 minutes given. Okay, maximum 20 minutes we will give. That also is not required. Okay, from 8 to 8:15 will be your test. Okay, on 29, keep yourself available and be ready in the morning hour. A link will be sent in your Google group. You will click it, write your name, your roll number, and you will start answering the questions. Simple questions based on this theory background will be asked. Okay, 10 questions will be asked. We will convert it into 5 marks. You are supposed to get a minimum of 2 marks a pass mark. And if you're absenting, you will be debarred, means you will be prevented. Debarred means you will be prevented to fill up the form for university examination. If you are not attending this examination, because only one exam we are giving, because of the pandemics, we are not able to do more than this test. So in this only one test, you are supposed to attend it and pass in it also. Okay, so please study the theory portions, everything related to the properties of matter and related to the G by bar pendulum. We will not ask anything about Cater's pendulum, but we may ask what is a compound pendulum, okay, and how does it work. Some simple question, multiple choice questions will be asked. What is G by bar pendulum? How does G value varies in different places and things like that? What is the least count of a screw gauge? What is the least count of the vernier? Okay, and what is the formula for this Young's modulus? And related to these questions, we may ask you. We will not ask you anything out of this questions. Okay, simple questions. Try to study the formula, the units and things like that, and make yourself available, and please try to get minimum of 2 marks in the examination. Hope this is clear to you. If you have any further doubt, you can ask me through WhatsApp. Okay, thank you for watching this video, and hope you will be able to be ready for 29 test. Okay, see you all. I'm ending the session over here.